you guys. So we need to finish the notes that were attached last week. Okay, the properties of exponents. I think it's lesson one, properties of exponents. Um, we still got to finish that, and we have to finish the cheat sheet, which is for this next rule. So far, we've looked at what's called the product rule. So that's what do you do with the exponents when you're multiplying, right? So two parentheses touching each other, it means multiplication. So you add the exponents. Okay, those are the rules here. This is what we did. We've already done this. Okay, so the next one is what's called the power rule. Okay, but some books they call it power of a power. Maybe I'll keep it simple. And you got the product rule, and then we've got the power rule. So the one important thing is, can you notice the difference between the product rule and the power rule? Okay, so look at these problems. So A and B, that's using the product rule, okay, because we're multiplying. All right, so if you have an exponent raised to a power and then you raise that to a power, that's the power rule. Okay, and it says that you again, you're going to keep the base, but you're going to multiply the exponents. So what I've done is I've multiplied m and p. So as an example, let's say we have a base of b to the third power, and then that's being raised to the fifth power. Okay, I mean, if you were to expand this out, you would have 3b's 5 times. Imagine that. So 3b's, but 5 times. That means you would have 15 of them. So that's the reason why we end up multiplying here and not add. All right, so look at the difference between this problem and let's say this problem right there. So notice how you're multiplying two things that have exponents. This one here, there's only one thing with an exponent, but then it's being raised to an exponent. That's why it is a power rule. It's a power of a power. Okay, don't worry about that. That's what I already assigned. So let's see who is correct here. Is it Casey? Is it Carmen? Or is it Albert? Who did the rule correctly? Okay, so one thing students might think about, they might want to square the base. But no, if you remember these rules, you don't change the base. So I know Casey's wrong because they changed the base, right? The base of 5. Carmen, well, let's see. Carmen, hey, look, she kept the base. Perfect. But look here at the exponents. She used the rule for the product rule where you add the exponents, but you don't add the exponents. You're supposed to multiply the exponents. This is different. So think about it. You have four fives, and then you have it twice. So 4 5s and then another 4 5s means I have 8 5s, not 6. So remember, you keep the base and multiply. So Albert did it right. So here's some more examples. So these are a little bit more, this is a little bit more challenging because we're doing the rule more than once, but that's okay. It's a pretty easy problem. So just ignore this 4, this bracket with the 4. So let's just use the rule, apply the rule inside here, and then we'll apply the 4. So let's do one step at a time. So I have 2 to the third raised to the second power, right? Which means I'll keep the base and multiply the exponents. I'll get 2 to the sixth. Now I have 2 to the sixth raised to the fourth power, which means I'll do it again. Keep the base, multiply the exponents, and I get 2 to the 24th. Okay, so it's actually a really easy rule. You just got to know the difference between the product and the power rule. So think about this one. Think about this one in your head. What are you going to, how are you going to do this one? right? You could probably, if you got it, you can probably do it in your head. So keep the base, multiply here, get x to the 10th. Keep the base, multiply here, and get x to the 30th. Okay, super simple. Right? You got Keanu Reeves. I always wondered what x to the second power to the third power to the fourth power to the fifth power is. Well, we can actually answer that. X to the second to the third is x to the sixth, to the fourth is x to the 24th, and then to the fifth, 24 times 5 is what, 120? So x to the 120? Easy. All right, so the key concept, power over power. Okay, to find the power of powers, multiply the exponents. So even if we're talking about like more than one, so this is just sort of a general rule, even if there's more than one. Okay, so we have a base with an exponent times a base with an exponent, and they're both being raised to an exponent. So we'll just keep the base, multiply those exponents, and then we'll keep the base and multiply those exponents. Done. Okay, so same thing here. Now here's where it gets a little tricky. Okay, I mean, I almost was going to take these out, but it's really not that hard. But you see this 2 here? This 2, do not multiply the 2 times the 5. Do not multiply the 2 times the 3. The only thing the 3 is attached to is the y. It's not attached to the x, it's not attached to the 2. So the y is being cubed. The x doesn't have an exponent, it has a 1. The 2 has a 1. So we're going to do 2 to the 5th. So 2 to the 1 times 5, which is 2 to the 5th. And then x to the 1 times 5. Okay, ignore the 3 right now, which is x to the 5th. I mean, I should have put a 1 times 5 here. It's the same thing. And then this is y to the 3 times 5. So now you deal with the 3. Okay, so the 3 is only attached to the y. Okay, now if this number is doable, like this 2 to the 5th is doable, we actually need to multiply that out. We're not going to leave it as 2 to the 5th. But if it was like, 2 to the 100th, I don't expect you to give me what that number is. But we can take 2 and multiply it 5 times. No problem. No problem. Right? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. So that'll be 32. And then we got x to the 5th and then y to the 15th. Okay, and then that's simplified. That's it. All right, now students will make this a 10. Or what they like to do is take this 3 and attach it and then make it 15. No, this 3 is only on the y. You separate each base. Each base has its own exponent. They don't share exponents, but they are sharing this 5. And that's why we have to apply it to each of them because of those parentheses. Whatever's in the parentheses has this 5 as an exponent. Okay, so take a little bit of time and try those 2 examples. Okay, like pause it, pause the video and try it. Okay, so once you've unpaused, all right, apply the rules. So again, remember this 4 is only with the y. This x has an exponent of 1. This is the power rule because these are all being raised to a power. We have bases being raised to a power. Bases with a power raised to a power. Okay, so remember that one has a little 1. So 1 times 6, 4 times 6, and we get x to the 6th, y to the 24th. All right, how many of you got it correct? Raise your hand if you got it correct. Look at you. Good job. Good job. Look at you. Getting it right. Okay, this one's a little more challenging. This would kind of be as challenging as we would see it because we've got a number in front. Okay, we can call this a scalar. We've got a base with an exponent, a base with an exponent, a base with a 1 exponent. Okay, so we have to apply the power, the power rule. So 4 squared, a to the 4th squared is keep the base, multiply the exponents. B to the 9th squared is keep the base, multiply the exponents. And then C squared. And if you want, you can think of it as a 1 and put 1 times 2. I just attach the 2 there. If there's no exponent, just put that power there, okay? Like I did here, 4 squared. So don't forget, remember, if this is doable, like 4 squared is doable, so that would be 16. And then a to the 8th, b to the 18th, c squared. And there it is. Okay, how many got that one right? All right, good job. Good job. Okay, so I guess that's it. Thanks for watching.